Well, welcome back. We have with us today semi-retired petrochemicals and chemical industry SME Bill Valerioti, also affectionately known as Bill Val.
Since I've worked in both, maybe I ought to spend a little bit of time, sharing some huge differences that, again, I'm a bit dated. This is the 80s and the 90s, but I went from, spending a lot of time in refining, supporting the units I briefly mentioned. And, at the time, and even today, I think the word is there's a plethora of information that supports refining, right? Another chapter book that I kept close by was API Refinery Equipment Inspection Guide. It was chapter 2 or chapter 3, I think, of a 12 chapter set. And it was great because it was practical knowledge and information about corrosion damage mechanisms in refinery processes and refinery equipment. And so I absorbed that, highlighted that. And what I'm trying to say is there was a lot of good knowledge and information about refining equipment, refining processes,
Mhm.
crude units, HF alky units, sulfur units, Klaus units, cat crackers, coker drums, right, boilers. So there was a good basis, a good foundation of knowledge to learn. When I got to the chemical side, the manufacturing facility in Houston and the chemical branch, there was a whole lot less information to rely on. There was
That's
there was less sharing. The chemical divisions were a little more secretive. They had proprietary processes. Even if they had some commodity chemicals they were producing, there wasn't as great of exchange of information at the time. So the learning curve was much greater. So therefore, the relationships with the process technology people that understood those chemical processes, the chemical plant operators, and the chemistry people who really understood the benchtop chemistry and the catalyst chemistry, also important in chemical processes. So that was a huge difference. What I found when I transitioned to in 1993 was I went from a world where there was a lot of good information. Some of it could be applied to damage mechanisms in the chemical industry, chloride attack of austenitic stainless steels and CUI and external chloride stress corrosion cracking are shared, unfortunately, in the chemical industry as well. So those learnings are transferable, but the maturity and the level of expertise I did not see within my experiences in the chemistry. We had to build that and establish that in the day. Today, it's much better. There's resources. There's a little bit more sharing. Materials Technology Institute does a great job of sharing some chemical technologies. 571 has some go by damage mechanisms for some more chemically, oriented processes. And that's a good thing. So there clearly are outlets. There's a lot of good ways to learn that. But what I found was the refining industry, fixed equipment inspectors were more advanced in the refining industry at the time than in the chemical industry. Not so much today. I think it's more in par the skill set, knowledge base, and so that's a good thing.
I saw, I came out of the chemical industry and then went into the refining industry and chemical industry and other things. But so my early experience was with NACE a lot back in the 70s
Yeah,
and the 80s. And I was blessed to be at a very large chemical facility at the time that had just fantastic group of
yeah,
materials engineers.
yeah,
And then I got really involved in API.
yeah.
I haven't really been involved with AMP at all. I think I quit being involved when it changed from NACE to AMP. I don't know why. It just seemed that's what I gravitated toward was more API. But do you see a difference in well, let me back up. In my limited experience, I see NACE and API or AMP and API as the same, only different. They kind of have different focuses, if that's a word. As a chemical operator, we relied more on NACE than on API. When I came to the refining industry, we relied a lot on both and saw how they kind of fit together. Does that mean anything? Do you see anything in the differences between those way the two operate and share information and get information?
Yeah, I do. I do recall the companies you worked for, and they were some of the premier materials, experts in the world were for producing and writing for some of the big names in the chemical industry.
And let me add one other thing too to that, Bill, is that one of the things that really impressed me where I was is those 25, 30-year experienced corrosion materials engineers. When I was wet behind the ears, 28 years old, putting my parachute harnesses on and stuff like that, and jumping into equipment, that corrosion engineer's right next to me with a camera inside of there taking pictures and saying, okay, you just went through this training course at University of Missouri, Rolla. Look at this damage up here.
Yeah.
What does that look like in the heat affected zone? And I don't know that people get that anymore. And of course, I said, oh, that's chloride stress cracking, because that was the sexiest thing to talk about, right? He was like, no. He said, this is actually accelerated corrosion in heat affected zone. If we could have solution and deal with this, we would have this issue, blah, blah, blah. But do people get that kind of experience anymore? I kind of crossed things. I went from API to NACE and what they've contributed historically to the importance of that seasoned corrosion materials engineer working with collaborating with the inspector. So that's two different things, really. But so if you would address that, the NACE API, and then how important is the collaborative relationship between the inspector and the corrosion materials engineer?
So those are good questions. And I have recent experience, I have long-term experience with NACE and recent experience with AMP, having recently been the chairperson of the high temperature symposium, which I haven't done for 2 years now. But I would say that AMP is different today than it was as NACE, by design. They incorporated the SPC organization and polymers, coatings, and what have you, testing. And so it's not the same. Your observation about, where the chemistry industry looked for knowledge and information clearly in the day was NACE versus API, and the refining industry clearly looked to API, ASME, as the case may be. I think, the last conference I went to was Denver in 2023. I mean, the 2026 conference is going to be in Houston. That's an interesting opportunity since, I'm close to Houston, what I'll do there. I think AMP is still probably more suited. When I think about who I work with on some committees at AMP, chemical companies were more represented. I think Materials Technology Institute is a great outlet for chemical companies. And if you look at their list of supporters and subscribers and sponsors, you'll see a lot of good chemical companies. So I think I don't want to make any holistic judgments about, AM versus MTI. I have some personal feelings, but I really, I value both, but I really highly value the work and the approach that MTI and the place and the books and the publications that they have on damage mechanisms, on welding, on specific chemical processes from hydrochloric acid to sulfuric acid, hazard chemicals. And if you break out ethylene, ethylene has a AICHE, right? It supports an olefins ethylene users group. So there's a niche opportunity there. So I think it's important for practitioners and mechanical integrity people to consider some of those things, to put in, get in your budgets. The budgets are set already for 2026. If you want to attend a conference or get involved, that's great. Express that, but it needs to be in the budget. So be thinking about how to help yourself and help your company and make effective use of your time at those conferences. I'll get to your point now about spending time, with corrosion materials experts and inspection personnel. We brought on a young college graduate recently, and after spending a year with me and the corporate engineering group by design, this individual, this person had an office and an assignment in a manufacturing facility because we wanted this person to learn it firsthand and experience the manufacturing environment, the pace, the integration, the complexities of getting things done and learning in a chemical plant environment. And we can spend a whole hour on what it takes to be successful in a manufacturing environment. But again, it's about communication. It's about relationships. You want scaffolding? Well, you need to tell us where you want scaffolding, where, how much, what inspection techniques. You need to tell us how long, where you need it, when you need it. And so much of working in that environment is taking ownership and responsibility for communicating and controlling and leading some of those activities. And not everyone's cut out for that. It's a tough environment. It's fast paced. It's 24/7, 365. But I still think you should have some structure to that. The best companies, I think, and the most successful way to do that is with a structured approach of planned learning, some impromptu learning, unplanned outages, unplanned events, but turnarounds are a great way, solving problems, having the materials, people work with the fixed equipment inspection to support them, to spend time with them, helping them, dialoguing with them. It's essential. And there are some refining and chemical companies I know still do that. They have a rotation. They have a planned rotation of people, SMEs, fixed equipment, MI people. They rotate them to different units and spend time in various activities to help develop them. That is, I think, some of the best models to learn and incorporate formal learning, incorporate informal learning, soft learning skills, writing, presentation skills. It all matters, and make use of it. Take the time. One thing I would leave people with on conferences: don't underestimate the value of issuing a one-page trip or conference summary when you get back. Do it each and every time and send it out to your supervisor, to the plants you support. Go to that conference, take notes, talk to people. And you don't even have to write a 5-page narrative. I went to the conference. I want to thank the company for the opportunity. I attended these sessions, and these were the key learnings. That's all you have to do. You will gain such respect and value. And guess who's going to be at the top of the list on the next year's budget to get to go to a conference? So, you have to do that. Be smart enough to do that. And I think you'll be successful if you do that and getting opportunities. And then clearly, anytime you can implement a solution, a recommendation that the genesis of which was from something you learned at a conference, don't hesitate to make that link. Yeah. It's important. So middle management and upper management can see and learn the value in having their people attend and participate in those activities.
Bill, the concept of knowledge transfer has kind of been a theme here throughout everything you've talked about. Everything from, you mentioned AI, and I know that you've used some of it. You also mentioned the number of books, right? So two complete opposite ends of the spectrum there: generative AI, learning AI, hard copy books, mentorship, conferences. What do you think the future of knowledge transfer looks like in the next 5 years or so, 10 years? Is it something, do we revert back? You mentioned Inspectioneering's articles. Do we revert back to some form like that? Or do you think that there's a path that companies are going to start moving towards to be able to help the younger folks? I don't know if I'm allowed to say that, but the newer folks and even the middle to upper journey folks. How are we going to help them continue to learn?
Okay. Yeah. I really like that question, Brendan. I have some, personal experience about, how I learn and how I, have evolved in my learnings. And I have. You mentioned hard copies of books. I probably mentioned that myself, but on Kindle Reader here, I have no fewer than 6 technical books on there. You can't see that, but I have Welding, Metallurgy, and Welding by John Lippold. I have Anthony Sofranos, retired mechanical reliability expert with ExxonMobil. I have welding volumes. So I think electronic learning, I think what I've accepted is people can be successful doing it a different way. For years, I was stuck in the mold. Was when I was interviewing, I had to really be careful of my biases. If the person wasn't, kind of aggressive and kind of like, really on point and jumping out there aggressively to communicate and had tremendous amount of hobbies, but they were more laid back and passive. I had to accept that, people learn and can be successful in different ways. And so I learned a lot about that. And young people I've been exposed to in the last 7 years because I've been on the recruiting trail and interviewing and meeting young college graduates and young inspection personnel, that they learn differently. They learn by searching. I think we had an example you're familiar with, Brandon, where AI did a fairly incredible job of really digging into the chemical equations that support how organic acids can be formed in organic solvents if they were exposed to impurities like oxygen, water, and chlorides and what have you. Now, the best time to evaluate AI, or the best way to do it, in my opinion, is to take an area you're very, very familiar with and pose some questions to AI and evaluate the responses. And I have to tell you, not only in the example I just shared, but in other searches I've done, I've been impressed. I've asked it flat out metallurgical questions. I've asked it weld filler rod recommendations to provide validations of what weld filler to use. And what I've learned is it does a great job of feeding back to you what's in the public domain. The what Inco or Rolled Alloys have published, what ThyssenKrupp or Bolt Alpine has published. Because if you've published an article in the public domain, their multi-million-dollar computer facilities are searching and identifying that. What it doesn't have is, what do they call it? Intrinsic knowledge, company knowledge of the way you do things and what filler rod you've selected from doing trials and writing welding procedures. So, but it really does a good job with the knowledge that's in the public domain. And so I'm impressed with it. Take it for what it's worth. I'm sure it's going to get better. But I hate to be the one saying this, but I can see in the future, more and more companies relying and having their engineers, be it chemical engineers, being maintenance engineers, being fixed equipment inspection personnel, using AI, to ask metallurgical questions and get some sense of the boundaries, of this doesn't work, so don't go there, but how to solve problems. And the other thing, and this is a little bit simplistic, but in terms of, what I'm doing now and what I'm spending my time in is being semi-retired, mostly retired, is I've always appreciated that having knowledge of materials and their properties is great. But if you can't join them and they're not very weldable, or their properties go the heck in a handbasket when they're welded, you don't have a practical material that's going to find many applications. So from the get-go, I respected and appreciated welding, welders, the ability to make a quality, high integrity weld, and the implications and the effects of welding on the properties, the microstructure, and the performance. So I've been taken for the last 4.5 years really into learning hobby welding. I do GTAW TIG welding and GMAW MIG welding. And to the point I'm trying to make is I've learned a lot over the years, being very involved in welding procedures, watching welders, talking to welders, looking at failed welds, looking at electrodes. I've learned a lot from welders, but I didn't spend enough time under the hood, as they say, where you can actually see the weld puddle. To my point about technology, I've learned a lot about welding from YouTube videos. Okay. To the point, it's a tremendous way to have experts demonstrate techniques of TIG welding, pipe welding, 6G welding, heavy wall welding, positioning, the TIG torch, the MIG torch, MIG welding. I've spent time on carbon steel, stainless, nickel-based alloys, aluminum. So there's so many ways to learn now. If you don't have access to spending time with a welder and actually, getting the welding hood on and looking over the welder's shoulder, or getting a vantage point where you can see, the arc being struck and the weld puddle and how the weld puddle is agitating and how the movement of the TIG torch, ties into the sidewall in a root and melts the base metal. And I've learned a tremendous amount from, again, reading, learning over the years, working with great welders and welding engineers, reviewing procedures, company procedures, talking to QA, QC people. I mean, a lot of the QA, QC people and NDE people started out in welding. And it's funny, again, your perspective. I have a good friend, Ken Harris, who recently retired, and I view him as a close friend. And he's a blessed man, and he's a determined, strong man. He continues to help me and share ideas with me. And I was sharing my love of hobby welding, and he listened for a while. And at the first opportunity between breaths of my narrative, he said, something? He said, yeah, welding is a lot of fun until you have to do it as a job, as a living. and then it's not too fun. And I had to laugh and say, okay, I understand that. But I would say, a lot of times you look at a weld and there's not a lot of high quality, or, the visual appearance isn't quite right. And it isn't all there is to look at, as you very well know. It's a volumetric inspection that matters, and what's going on subsurface. Even if you follow the procedure, there's still a lot depends on the skill and the determination and the rigors at which the welder executes the weld. And what I've learned is there's not just one thing, or there's only one important thing about welding. Everything about welding, from knowing what you're welding to the technique you're going to use, having a procedure, following the procedure, your tungsten, maintaining your tungsten and good quality cleanliness. You can't be clean enough in welding. But when you're running a TIG bead, you learn a lot from the puddle. Right away if you're having issues. The weld puddle is agitated, it's gassing off, the arc is erratic. You might as well just stop. If you're getting porosity or the weld isn't behaving properly, you can rest assured that something's not right. And I've learned there's so many ways to screw up and contaminate a weld. And that's a whole nother topic of discussion.
It's a good one.
What I'm trying to say is how I would turn around. Again, it was an experience I'm not proud of, but we were having some problems welding some iron nickel-based ethylene alloy materials. And there was a number of reasons posed about why we were having a problem, from the electrodes, the wire quality, to the gas quality, the argon quality. And, I was taking information second and third hand about what the problem was and what the experience was. I should have known better. I should have got out of the office a few years ago and, got qualified to go inside the furnace and get a welding hood on and talk to the welder and watch him putting in, the weld bead. So I would leave fixed equipment inspectors, analysts, QA, QC problem people to, when appropriate, when it's important and things are not going well, get as close to the firsthand experience and that the person who's executing and finding it difficult and talk to and see if you can observe that activity. You'll learn a lot is what I'm trying to say. Okay.
Does this
Well,
tie into, Bill, what you said earlier about if you're using, and I'm not trying to talk about AI here, but just as an example, the tacit knowledge. I mean, I've met guys that I would call blacksmiths that were some of the most amazing welding engineers, because you can get into some pretty hairy situations like you're describing now, right?
Yeah, I think it does matter. I think about the learnings and experiences that people bring to the table. And I think the more, you learn from your failures. I think it was Thomas Edison was said that he learned more from the 422 incandescent light failures and filament failures than he did from the successes. And that's the truth of it. And I think that, boy, I know, so many times I've been in conversations and, you hear, well, did you have a procedure? Did you follow the procedure? Was the procedure at the job site? Did you see the procedure? And unfortunately, in too many cases, they never did see the procedure.
The weld procedure
Yeah.
specification. Yeah.
Yeah. Yeah. I hate to put a percentage on it, but that's kind of the beginning of success. It really is up to not only the skill, but the determination of the welder to give you a good quality product. And of course, there's competing priorities. They need production. They need to get so many welds done, so many pipe welds, so many feet produced. Otherwise, they're falling behind what the contract stipulated. So there is a lot of pressures, and it's up to us to realize that it takes a certain amount of perfectionism, I believe, both from being an analyst and engineer in this industry. And the reason why I feel that way, and I've said it in a different context, but everything matters. And I haven't said it, but, one of the things we talked about before this discussion was what things in my career have made a significant, lasting impact. And for me, it's very clear. They were three major manufacturing plant incidents: fire, explosions, casualties, fatalities. Those ingrained on my brain a commitment, to the people, to the communities, and to the environment. And see, it's still even emotional today that I always wanted to give my best and represent in decisions and judgments the best that we could offer to do the right thing, because it all matters. Lives matter, businesses matter. Some of my companies, the businesses were no more after having declared force majeure for too many years. Other people, other products move in and take your place at the business roundtable, so to speak. So don't underestimate how everything we do, how it's installed, how it's welded, how it's erected, how it's inspected. It's all important, a day in and day out, and ongoing programs. So I would say people give it your all. It all matters. And you never know when a shortcoming may reveal itself. It may be upon initial startup, and maybe during the NDE that's done on it, but it could be years and years later. And whenever it happens, some of the worst feeling in the world is when you have a unit or piece of equipment that's involved in a breach of the pressure boundary or has a failure, and you start processing your role, your contribution to that unit, to that asset, to that equipment. There's a time you go through in the mental process where you break out in a cold sweat and wonder if, you may have had something you may have done, recommended, did do, didn't do, could have contributed to that shortcoming or downfall. And it's not a pleasant feeling. So I committed myself to endless hours of reading and learning and bouncing ideas off people and doing what we thought was right and correct. And again, a lot of times it was something we decided, but we couldn't implement right then. And so now we rely, thank goodness, we rely on risk-based inspections and risk modeling to help us understand any benefits by re-inspecting, doing another inspection. Is this damage mechanism, or is this shortcoming? Is it detectable through inspection? Can we learn more about the state, the condition? It doesn't matter if we go back and reinspect it and, can defer, this repair. Can we add acoustic emission monitoring, or what can we do, to buy some time, so to speak, because it's not a good time to take the unit down. We don't have the resources, what have you. So we do that with greater knowledge and information today. And I think we can make better decisions because of the advancements in the technology and the analyses that are available and that we can do today, and where the industry is advanced. It's not a blind, well, yeah, I think it will be all right. My gut tells me that this typically takes 4 to 5 years before it manifests itself, based on my experience. Well, we'd like to hear your experience, but we'd also like to supplement it with, with some calculations or analysis. And we can do that today. And so that's important as well.
Yeah, that's exactly what I tell inspectors when it comes to RBI. Leverage the RBI to help with that gut feeling. If RBI is sitting there, especially a quantitative or semi-quantitative version, is sitting there saying, hey, the risk is this, you can take that with you to management. As you've been saying, we need to do this inspection, we need to do this inspection, we need to get in this vessel. You can take that piece of paper and say, hey, here's backup, here's why. Definitely, I use that in training courses all the time, talking to people about RBI.
Yeah, it's a very good point. And the other thing that came to light when you said that, Brandon, was, I think you all know this, I think the industry is rapidly approaching the point where we'll have to go inside of very few vessels in the future. Now that's not 100% the case, but I think I read an article recently that the technology is so good when used properly, it's actually more reliable. The results and the findings are more consistent and more predictable than a human being. It's for a lot of reasons, but a lot of it is AI. And forgive me for the SMEs out there in AI and computer and software, but it's recognition, visual recognition, right? And so much is relied on, the inspector goes in with their experience and their tools and their eyesight in their mind and their database of, what am I seeing? What does it mean? Where am I seeing it? What does this imply? But once you take your eyes off it and a day later, a week later, it's just your memory bank. But if you have a digital laser scan 3D image, structured white light image, the computer can look at the profile. And particularly if you have a reference profile when it was new or only in service for years, it says, hey, wait a minute, this is different. There's something here that wasn't here initially when it was new, or last year, or last inspection cycle. But I really believe, and I wouldn't have said this probably 5 years ago, but I think more and more now we can get a look at the inside of the equipment or mid-wall equipment and understand. So the old days of having to go in and don your harness and safety ladders and recovery equipment and your escape pack. And yeah, I think we're moving to where so much more will be done extrinsically. Yeah, non-invasive. Do you agree with that?
I totally agree, Bill.
Yeah,
Totally.
yeah.
I can't tell you how many times at work that I'd be in a glass line vessel with a 5,000 volt spark tester and slip and fall because it was wet in there. And I'm underneath an agitator now, a glass line agitator. I got to get our ladder fell apart on me when I was, 20 feet in the air, Thank God I never was injured like that. Or the time I went into the vessel and I had everything lockout, tag out was right. I had the entry permits, everything. They had the lamb air movers in. I come out and it winds up that those 3 holes that I saw on the sidewall that were opposite the external jacket had nitrogen flowing through them because they were repairing the jacket. Mechanics were downstairs on another level repairing that. Why not avoid all that? If we don't have to go inside,
Right.
why are we going in there?
Right. I agree. It was kind of like the experience I had climbing up to the flare stack to get a look at some piping, igniters up there, the purge gas line. And I was not really comfortable with heights anyway. And I wasn't the primary inspector. I was the tag along, but the only thing I could share knowledge of was the part of the flare stack that you could see between the ladder railings. Cause I think that's the only thing I looked at the whole way up and the whole way down. So yeah, I wasn't going to be very valuable in my observations on that inspection.
And now they got drones doing all that
Yeah,
stuff.
yeah.
And they had the automatic cable crawlers that could go and inspect the cable going up. I'm hoping that the industry's getting closer to taking full advantage of those kind of things. I think part of that too is the quality of the inspection, because some of these things are heavily, like welding, some of these NDE techniques are heavily operator dependent. Some of them aren't, right?
Yes, I agree with that 110%, which raises another good point about not only NDT and NDE practitioners, but performance, skill set, qualification, and demonstration. And many companies have been doing this for years. I think it's correct when I say ANST has introduced some performance demonstration testing where level 2s, level 3s have to come in and do on mock-ups with samples with embedded known flaws, have to demonstrate their skills and abilities. And I think, not to pick on NDE practitioners, but our hats off to them for recognizing that it's a skill set, it's learned. There's fine tuning adjustments and comprehension. More of it is analyzed by computers now, and judgments are made that way. But even in welding, we had some higher end iron, nickel, chromium alloys that not everybody was skilled and versed at welding. So even though you had your ASM Section 9 card, 6G position, we still were having too many busts and too many failed x-rays and testing on these high alloy components that we implemented in shop skill demonstration of welders and their ability to run the iron, nickel, chromium alloys on these materials, because it was so important to us once we got in the furnace to have good quality work. So
absolutely,
I know, you feel at a time someone always wants to put another test or another exam in front of you, but it just serves to demonstrate the criticality of the performance and what we do and how we do it, the reliability, integrity, and quality of what we assemble and do in a petrochemical and refining industry. It's a very unforgiving industry. Hope is not a strategy. Hope and luck are not a strategy to success.
A really good buddy of mine who's a project manager said the 3 priorities are, in this order as well, are quality, schedule, and cost. Because if I mess up on those first 2, it's going to impact cost.
Yeah, absolutely. Good points. Absolutely.
I have one last question, Bill. I'm super curious. You mentioned that you're getting into the hobby welding. What are you creating?
So that's a good question. I've done a lot of practice on plate and honing my skills and abilities. And it's the hand-eye coordination. And really, when I'm looking under the hood, what am I focusing on? What am I taking in? But to answer your question, I've done a lot of fence work. I make a lot of bracketry and supports for wood or metal fencing that I have on a 1-acre lot. So I don't have a ranch or farm. I've done some metal art, not chickens or roosters, but I've done a scale model of the Eiffel Tower. I've done that out of rebar and stainless steel expanded metal. I researched the dimensions and the angles and the geometry of the Eiffel Tower and tried to mimic that on a 7-foot scale model of that. And I've done mostly TIG-tac welding, and then I've done GMAW MIG welding, but I've had to use on a 1/4-inch 220 volt, so I only have a 220 welding receptacle on the side of the house. So I had to move my welding, my Hobart welding gear out to the side of the house on the concrete driveway. I converted a 30 amp RV outlet receptacle. I had the electrician change out and put a welding, configuration of an outlet. I guess the one thing I would say, a buddy of mine who lives in the neighborhood I shouldn't say this, but he's from Arkansas. So naturally, he traps feral hogs, and he needed some help building some trap cages. The big farm, ranch, steel wire, mesh to the angle iron frame. His primary welder that he would turn to was backed up and he couldn't meet his demand. So I had mentioned to him when he was trapping feral hogs behind my house that I'm a hobby welder and that if he needed any work. So he took me up on it. I helped him build some feral hog traps about 3 years ago. And about 2 months ago, I saw him and he said, "Oh, by the way, those traps you built, they held together really well. They're still holding up."
That's awesome. That's awesome.
Many a feral hog in those. So
that's great. Yeah.
a lot of
I
fun.
was just over the past weekend, I was telling my wife that the next thing I'm thinking about is welding. We've got some stuff around the house and a couple different things that we're being able to have some welding and make a couple brackets or a couple tools or things out of steel as opposed to wood might be more useful. So anyways, Bill, I want to thank you so much for your time joining us today.
You're welcome.
This has been awesome. If we could do this like every single day, I'd sit with you and listen to you as much as possible.
Well, I appreciate
Fantastic.
that. I really do, because so many times when a metallurgist is speaking, people are glassy-eyed and looking at their phones. So I try not to be, but I just get so excited about the industry and the people. I love the people. I've always felt comfortable with the people. I could go on and on about how great it is. I guess one of the greatest disappointments for me was that none of my kids decided to follow in my footsteps, probably because they realized, how many hours, weekends and nights. Now, the blessing was when you support a manufacturing plant in Houston, you may be following in a lot of hours, but you're not traveling. And that was the trade-off for me. In corporate engineering, you're on a plane, you're traveling. When you're working the plant, the phone may ring at any time, but you're probably home sleeping with your wife and maybe seeing your kids every day and night. So you're welcome. I thank you, Brandon. I respect you and appreciate you.
Thank you.
Thank you, guys.
Thank
Bill,
you so
this is
much,
great.
Bill. This is
Thanks
awesome.
so much. Yeah,
You're welcome.
Thank you.
You bet. Bye now.
Take care. Bye now.
All right.
Thank you for listening to Upon Further Inspection, a mechanical integrity podcast. This episode was co-created by Inspectioneering and Core Solutions. Our producers are Nick Schmoyer, Jocelyn Christie, and Jeremiah Wood. This podcast is for informational purposes only and does not constitute legal or professional advice. Listeners should seek their own qualified advisors for guidance. If you enjoyed this episode, please join us next time wherever you listen to your podcast. Until then, stay safe and stay informed.